Hello, I'm Carly McAvoy. Today I'm talking about finding the equation of a line, and this is the fifth part in this series, and you can see all the different videos that we did before. At the top are the formulas that you might need as you go through this, the point-slope formula, the slope-intercept form, and the slope formula. So you can go to Emporium Mathematics on YouTube and find part 1, 2, 3, or 4 if that's what you're looking for. Part 1, we're finding the equation of a line from a set of points, given the slope and the y-intercept, and from a written scenario. Part 2, a line from a graph, an equation from the slope and a point, and so forth. So look at those and decide what part you need. This video, we're going to find the equation of a function using information about vertical shift. So when you're talking about a function, we use the notation f of x or h of x or g of x, whatever our function name is. And f of x could be a replacement for y, or g of x we could say is y. So you would graph that the same way that you would graph that if that was y equals 2x plus 4. So write the slope-intercept form of the equation of the functions f of x and h of x whose graphs satisfy the given conditions. The graph of f of x is the graph of g of x shifted down 6 units. And the graph of h of x is the graph of g of x shifted up 2 units. Well, then you're given what g of x is. So this is g of x right here, which is 2x plus 4. Our y-intercept is 4. That's where we cross the y-axis. If you go up 2 and over 1, you hit that graph again because our slope is 2. So if we shift that graph up or down, we don't change the slope. So if you think about it as, if you look at as a ruler, if I took that and just shifted that down, the slope would be the same, but I would cross the y-axis in a different place. Or if I shifted it up, same slope, but I would cross the axis in a different point. So where would I cross if I went down 6 units? Well, I'd go 1, 2, 3, 4, 5, 6. From 4, which is where my y-intercept is now, I would go down to -2 if I went down by 6. And that means that my slope would be the same, so I could go up 2 over 1 to find that slope. And it's not asking me to graph it, but I just want you to see what's happening. And so I would have this line that's parallel to the first one just shifted down. What would be the equation of that line? Well, or that function, I'm going to call it a function because we're just looking at function notation. That one is shifted down 6 units, so that's f of x. And f of x has the same slope, but it crosses the y-axis at -2. So what do you think h of x would be? You should be able to come up with that one on your own. H of x is shifted up 2 units. So here it is. And if I go up 2 and over 1, there's my next point. And if I draw that one, it's also parallel to the first one. If I drew a little better, you could see that they are parallel. But it's a parallel line to this first one, but it's crossing the axis 2 points higher than the first one. So that would be 2x plus 6. So there's writing an equation of a line, given a function, and then told to shift up or down. Okay, the second example is a word problem. And this one is, then you have to find the equation of a line that fits a particular scenario. So this one says, for the sake of argument, let's pretend that the height of skyscrapers has increased approximately linearly since 1900, when Philadelphia City Hall was the world's tallest building at 548 feet. The Empire State Building became the tallest building when it was built to be 1,250 feet tall in 1931. Find a linear function h of t, where h is the height of the building, t years since 1900. If necessary, round your slope to the nearest tenth. Okay, so we have two things here we're looking at. We're looking at, in 1900, we had a building that was 548 feet tall. And we're saying that t is the years since 1900. Well, in 1900, no years had passed. So my ordered pair is going to be 0, 548. That's my first ordered pair. My second ordered pair happened, the second building happened in 1931, and that was 1,250 feet. How many years had passed since 1900? Well, 31 years. Our T is not the year, but the number of years since 1900, and that was 1,250. So there's our 2 points, and we can use the same methods we were using in previous videos. We're going to use the point slope formula, or you don't have to. If you have another method where you just use a slope intercept form, that's fine. I'm using this one. I'm going to use this formula because it looks the easiest. Y minus 548 is, oh, I don't know my slope. That's what I had to do first, right? My slope, I subtract the y's on the top, which was 1250 minus 548, and my x's on the bottom, which is 31 minus 0. Now I can use my calculator to do that. I'm going to just subtract 1250 minus 548, and then I'm going to divide by 31. I can see 31 minus 0 without doing that on the calculator. And that gives me, it told me to round to the 10th, so approximately 22.6 is my slope. Okay, well I need that to do this formula. So now I have 22.6, and I have x minus 0, because the point I'm using is right here, and that point, no years had passed. It was 1900. I think Philadelphia held that on to like 1908, if I recall, from what I just looked at. So I'm going to rearrange this. Of course, I'm going to distribute the 22.6 and get that. And then I'm going to add the 548 to both sides. And I'm going to get this. So this is the y, but they asked me to find h of x, so I'm going to call that h of t. Sorry, I was using x, and h of t is 22.6t plus 548. I just used my formulas with different variables, but because they asked me to find a function h of t using t as the variable since 1900, I wanted to write that in the correct form. The second part of that asked me to predict the height of the tallest building in the year 2018. Well, I'm going to use this formula, and I want to know what would the height be and what would the year be. Well, since 1900, that would be 118 years. So what I want to do is replace the t with 118. So I have 22.6 times 118 plus 548. And that would be 22.6 times 118 plus 548. That would give me 3,214. I'm going to just round up. I don't know what they might ask for. Maybe they will ask for the 10th. So we'll say 3,214.8. So in 118 years later, if it was linear, we could approximate that it would be 3,214.8 feet. That was our prediction if it was linear. I did go ahead and look at what are these buildings actually looking like. Not quite linear, but this first one on the left is the Philadelphia that I mentioned, the Philadelphia City Hall that held the honor of being the tallest building. And then you can see they didn't go up exactly linearly, but there was kind of a linear thing happening there in the growth of buildings until we get here. You see how we kind of were going up, and then all of a sudden we took this major jag, right? And then this major jag, and then if you were to look at the whole thing, this major jag up here. So what are those buildings? Well, 2018 is the building in Dubai. That's this one. This one's yet to come. See how they build these really tall spires? So they don't really have to have anybody in there, but the spires make the building tall. See how they all have that? So they obviously just want to be the tallest building. But this building right here is in Dubai, and it's 2,000, I had it written down somewhere, I don't know what I did with it, 2,722 feet. And so we predicted 3,200, but we were off by 1,000 feet. So it wasn't a linear growth, but for our purposes, it serves to show you how you could find a linear equation, and it's kind of interesting to look at the buildings. This one has not been built. They're saying in 2030 they'll have a mile-high building. Pretty interesting. All right, have a great